Logistic regression is a let's go method. It is being used mainly for the binary classification task. The term logistics comes from the logit function, and that is used in the method of the classification, because there can be the logic that is 0 or 1, or we can call it as true or false also. So the logistic function, also called as the sigmoid function, which is S-shaped curve that can take any real valued numbers and map it in between 0 or 1. We could see this particular example in which, based on the CGPA, we are providing the admission to the student. So definitely, if we are talking about the admission, either the student will get admission or the student will not get an admission. That only two cases, or the binary classification is over there. 0 means no admission, 1 means the admission. So here in this case, it is categorized based on the CGPA. So the student having the CGPA almost less than 6, okay, or almost less than 5 is not granted an admission, and the student having the CGPA that is of 8 to 10, so it will get an admission. So in the similar way, so the logistic regression will provide you the outcome. So let's assume that the example, like your little brother is trying to get into the school and want to predict whether that he will get the admission in the dream college or not. So based on the CGPA and the past data, you will use the logistic regression to foresee the outcome. So the logistic regression allows to analyze a set of variables and predict the categorical outcome. So categorical outcome, either the admission is or the admission is no. So here we need to predict whether he will get into the school or not. So this particular problem is a classification problem, and definitely the logistic regression will be a ideal case. So logistic regression is used to predict the house values, customer lifetime value in the insurance sector. The next, that is the support vector machine, or called as SVM. It is a unique in the sense that it tries to sort the data with the margins between two classes as far as possible. So this is the maximum margin separation, we can call it. So another thing to note here, the fact that SVM take into the account only the support vectors while plotting the hyperplane. So like the linear regression, which uses the entire data set for that purpose. In case of the linear regression, like you want to identify the house price based on the available data, you will see like what were the square meter area and what was the price. So accordingly, out of that, you can predict the house price. So here in this case, the SVM quite useful in the situation where data is of higher dimensions. So if we want to understand it, let's take a look at this particular example. So in this particular figure, we have to classify the data points into two different classes. The class of the square and the class of the triangle. So for that, you want to classify. So as shown in the picture, uh, the margin is shown and the hyperplane is shown, and there are two support vectors, one for the identifying the margin for the square, and one identifying the margin for the triangle. So you start off by drawing a random hyperplane. Then you check the distance between the hyperplane and the closest data point from each class. So the two classes and the hyperplane, like that hyperplane you can draw over here or over here. So you try to identify the support vectors. Uh, so here in this case, these two support vectors we could identify. So the closest data points to the hyperplane are known as the support vector. So here in this case, for this hyperplane, this one, the circled square is a support vector, and this circle triangle is a support vector. So the hyperplane is drawn based on this support vector, and the optima hyperplane will have maximum distance from each of the support vectors, and this distance between the hyperplane and the support vector is known as the margin. So the distance between this support vector and this support vector will called as the margin. To so to understand, SVM is used to classify the data by using the hyperplane such that the distance between the hyperplane and the support vector is maximum. The next algorithm, that is KNN, is a non-parametric non-parametric essentially means it does not make any assumptions on the underlying data distribution. So KNN, that is the K nearest neighbors, it is a lazy learning algorithm. So lazy means the training is very short, so that's why it's considered as lazy, or you can say a fast, because the training phase is very short. So its purpose is to use the whole bunch of the data points separated into the several classes to predict the classification of the new sample point. So the following points serves as the overview of the general working of the algorithm. A positive integer n is specified along with the new sample. We select the n entries in our database which are closest to that new sample. We find the most common classification of these entries, and this classification we give to the new sample. So there are some downsides of using this k nearest neighbors. These downsides mainly revolve around the fact that KNN works on storing the entire data set and comparing new points to the existing ones. So this means the storage space increases as our training set increases. Okay. This also means that the estimation time increases in the proportion to the number of training points.